Hi folks, welcome to Dr. G's WTW Science, and we're so excited today. We've reached 100 subscribers. 100 subscribers. So thank you guys for embarking on this amazing journey of discovery and wonder. We have guys as young as 3 all the way up to 78. So thank you for sharing your comments. Thank you for collaborating and also for sending us some awesome videos. So today we have a really simple experiment that demonstrates Archimedes Principle, or the idea of buoyancy. Buoyancy, or the ability to float. All right? So the question we have is, what would happen if we popped a couple of raisins into a glass of water as opposed to popping a few raisins into, say, a glass of Sprite or carbonated water? So let's just do that very quickly. This experiment is also referred to as the dancing raisins. I would like to call it breakdancing raisins. Breakdancing raisins. So there's some ordinary water in there into the glass. Right, and then very quickly, so what I'm going to do is just pop a few raisins in there. And they all sink all the way to the bottom as expected. And what would happen if I now took Sprite or some carbonated water, not too much of it, and there we go, and put in similar raisins in there, and we don't have to wait very long, and we're going to see something amazing happening. You'd find that the raisins sink to the bottom, and some of them are just very happy to float to the top, and as they get to the top, they then, for some reason, float all the way to the bottom. But if you have a quick look at those raisins, and because they're very wrinkly, you'd find bubbles forming on their surface. All right. So what these bubbles actually do is not just make them not lighter, but less dense by increasing their volume. So as the bubbles accumulate on the surface of the raisins, we've had one going earlier on as well, so it's pretty well behaved as well. You'd find that they would rise to the top, and as they get to the surface of that liquid, the bubbles break off, and the raisins will fall under their own weight all the way to the bottom. And the process repeats itself. This is hours and hours of fun, much better than staring at the TV or into your cell phone screen. So,
can you use Coke?
What? Use Coke? Yeah, I'm sure this experiment will work, but you will not be able to see the raisins bob up and down. You will see them breaking the surface, but that really amazing dance that you see in the Sprite or carbonated water, you're going to miss. It's like looking for the wood when there are no trees. So, what I love about this experiment, and it's a very rare one when it comes to experiments, this is one of those experiments where you can actually taste, eat / drink your experiments. So cheers.
1.
Hi folks, welcome back. And yeah, we're still on the principle of Archimedes as well as buoyancy. And you can see the raisins are still going, and that's hours of fun there. But ever wondered how a fish basically rises or descends in water or even stays in the same spot? You know, it has a swim bladder. And how does that work? Well, what we've done here was we created something called a Cartesian diver. Very simple to make. Just use a 2-liter soda bottle filled with water and get one of these sachets that you have from a restaurant, one of the takeaway ones. This one's filled with vinegar, then you have the ones with sauce. You can be really creative. You can use a straw to create a Cartesian diver, syringe, a pen cap like this. You've seen all of that. And even one of these, you know, a lip ice or a labello cap. So all I did here was to use a sachet, and I weighted it slightly a bit, and all I do is very simply just press onto the bottle very gently, and almost at will you find that that little diver sinks to the bottom, and when I release the pressure on the bottle, it rises to the top. Now if you use your common sense, and if that cap was removed, you'd find that when you press, the water shoots out of the bottle. With the cap on, you'd notice that almost against common sense, the diver floats all the way to the bottom, and then release that pressure on the bottle, and the diver now ascends or rises all the way to the top. So why does it do that? Well, if you took one of these little packs, you realize that it's not completely filled. It has a little air pocket, a little bubble inside there. So when I press onto the bottle itself, that bubble gets smaller. It gets compressed. So the air inside gets compressed into a very small space, which increases the density. Doesn't change the mass of the packet. It changes the density of this little packet, and that will sink all the way to the bottom. Now it makes sense when I take the pressure off or remove the pressure off the bottle, then that little tightly squeezed air bubble will now start growing larger, increasing in volume, thereby decreasing the density. So the Cartesian diver works primarily on the change in density. So I'm hoping that we'd have lots of fun. Look, these raisins are still having a ball. They're going up and down, and yeah, so really cool stuff. Hope you enjoyed this. Like I said, comment if you wish. Send us a few videos. That'll be so awesome to even collaborate with you guys. And don't forget to subscribe. Thank you very much.